Okay. So our lecture this week is starting March 6th. Our lecture is about introduction to Python. Hopefully this won't be too strange for you or new, because I've tried to show you a little bit of Python as we go. A couple other things I should mention. So this week we have a lab to do. Actually, we think we have two labs, Lab 7 and Lab 8, and they are working with Python. And we also have some extra assignment things to do. So please have a look at that. It's on the news for this week. Have a look at that, and maybe I'll refer to that at the end of this lecture. So let's look at Python. As I said, you've seen a little bit of Python as we've gone, and you may have noticed some of these things being true, that we do one instruction per line. Now you can have instructions that are a little bit compound, but this is a little bit different than some other programming languages. So for example, in like C or in Java, as long as you use your curly brackets, you can use curly braces to put lots of stuff on a line, right? Others, you'll have a semicolon at the end of every command. And so, yeah, sorry, I'm going to talk to the late people. We'll sort out your attendance later because we're like 10 minutes into it. The other point that's made on this slide is about the hash symbol. The hash symbol showed there. Anything to the right of a hash symbol in a Python code is treated as a comment, and then it is not executed by the Python interpreter. All right, so we can use that to insert our comments into the code, and maybe you've seen me do that in our Python as we've gone. The other thing there, very important, and I hope that you've already seen this as well, is that we use indentation. It is so important in Python. Now, the thing that we do in Python to make that possible is we use a colon whenever we have a control structure. So for example, when we start a function, or when we start a while loop, or when we have an if statement, we will use a colon. And then if we hit return, you'll find that the idle, which is the IDE stands for an integrated development environment. The IDE editor will put your next line of code in the exact right place. So you shouldn't have to touch backspaces and tabs and spaces. And you'll usually find that if you are touching backspaces, tabs, and spaces while you're writing your Python code, that you're probably going to get these errors where it says that the indentation is not right. And so just to get the indentation right, make sure that we always use a colon to start our control structure. And indentation is so important. Next on our variables, and you may have seen this before. Now, remember in our pseudocode, whenever a variable was first used, we had to specify what is the type of that variable. So for example, if we wanted to use an integer number, we would specify in front of the name of the variable when we created it, we would say int, indicating that was an integer. You don't have to do this in Python. Python will infer the type of the variable by whatever you assign the value to it. So when you create a new variable, you just assign a value to it, and Python will automatically determine the type for you. So that's really kind of nice. It does lead us to an issue sometimes where Python assigns the type and it's not the type that you actually want to use, in which case you can specifically change the type, and we call that casting. And you'll see that a little bit later in this lecture as well. Now, the other thing about variables in Python is they are case sensitive. And so the example here in green at the bottom of our slide is about 3 different variables. Now, you would look at them, I would look at them. If you saw them in an English sentence, you'd say, oh, those are all the same. They're not the same in Python. All right, so these could be 3 different variables because of the differences in a capital L is different than a little l. And so it's a very different thing. The other thing about that is we use lower camel case for our variable names. That is, we start our variables with the lower case letter. We can also start our variables with an underscore, and you can use underscores and some other characters in there. Be careful with the other characters, but underscores certainly, dollar signs, things like that you can use in the variable name. You can also use numbers, but you can't use numbers to start, or special characters to start the variable name. So the variable name should start with an underscore or a letter of the alphabet, and preferably a lowercase letter. You could use an uppercase letter, but we don't. I mean, you'd use that for a constant. We talked about that in a previous lecture. And so, as mentioned, and this also came up in previous lectures when we were talking about pseudocode, etc. There are different types of variables. The type of variable depends on what we're going to do with it. And so we have a couple of different number types. We can have num, which is going to be treated as an integer. We can have decimal or float. Here we see a float number, which has a decimal to it. We can have a, I'm sorry, these are variable names. Yeah, we can have float. The types are integer, float, and string that we're using here. These others are the variable names. So yes, we can have integer, float, or string. We can have char, other variable types. Yeah, I think that's all we're going to sort of use. We can have more complex variable types, such as a list or a dictionary. When we use the string will be our introduction to complex variable types. And what I mean by that is the string is actually a variable type which holds within it. It's like a complex variable, because the string, you can think of it as made up of a bunch of characters, and each of those characters in the string can be individually accessed. And you'll see that. I think that comes up in a later slide. So what I mean by that, here we're assigning a variable called sentence. We're creating a variable called sentence. We're assigning it the value, and we can tell it's a value because it's between double quotes. So this is a string. Each one of those characters in that string, including the spaces, can be identified and can be used separately. And so they would be like, this is the character at position 0, position 1, position 2, position 3 of the variable called sentence. So sentence then is a variable that has been assigned a string, and that string is actually made up of a bunch of characters. So that's what I mean by it's a complex variable. It's a variable that's made up of other little variables. I guess you could think of it that way. All right, so we've got a couple of different we have a couple more different variable types that we can talk about. First one here, integer numbers. Integer numbers do not allow us to use the decimal. All right, so that's just we would call them whole numbers. They do include negative numbers and positive numbers, but basically all your counting numbers, but add to that your negative numbers. We've got some little symbols here that we use for our mathematics. We can use those for our integer numbers and for our float numbers for that matter. This means to add two things together, subtract. We use this for multiply. We don't use an X or anything like that. And you can't just put a brackets around something and put something on the outside like you do in your mathematics and say that's a multiply. No, you actually have to explicitly use the star symbol. Star symbol found above the 8 on your keyboard. We have a special kind of division. So this symbol here is used for division, and you see it used twice here. That's a special kind of division. That's a division where when you divide one number by another number, the remainder, if there's a remainder, the remainder is truncated or lost. And so the result will be an integer number. So we call that integer division. The result is going to be an integer number. We remove the remainder, the decimal part. So if, for example, if you took 10//3, that would give you a result of 3.333 if you had a float result. But the 0.333 would be gone. So 10//3 would be 3, because there's 3 with the remainder, and we throw the remainder away. We truncate the remainder. If we want to get And so therefore we use the two different terms for them. We say integer division to give us a division with which we remove the decimal part, or decimal division, which is a division which you're familiar with, which is going to give you a float result. I hope that makes sense. All right, so floating point numbers are going to be useful if we need to do that kind of thing. Whenever we do a division like this, we should expect to get a float result. Unless we divide by 0, which is not really allowed, right? So that's another thing when we start doing our calculating, you know, in mathematics, so you can't really divide by 0. The computer program kind of knows that too. And so if you try and divide by 0, you will get an error. All right, so this here in the slide, it refers to converting. You can convert a number that you have, maybe it's an integer number and you want to use it for some kind of special calculations. You can convert an integer to a float by a process that we call casting. How we cast is like this. You say what, you use the type of variable that you want to cast it as, and then surround the thing that you want to cast with a brackets. And what will happen is after this, my variable will be changed into a, or the result of this will be a float. So that's the type of thing that we remember. The inputs, you've seen me do a lot of Python programs so far. I've been trying to do this to make this part of the course easier for you. I mean, I'm hoping that this part of the course will be easier for you because Python is not new. You've seen it. You've seen it. Now you have to do it. But you probably might remember that whenever I do an input and I want a number, I will put an int around the input, because otherwise it would just be a string and we wouldn't be able to use it. I mentioned a minute ago that strings are a special complex type of variable. It's a variable that is actually made, the contents of which is made up of a bunch of characters that are addressable by an index. So when we create a variable called greeting and we set its value to this, what we're actually saying is a bunch of characters, H through, in positions 0, 1, 2, 3, and 4, have these values. And so we can work with that, but it means we can actually break that up. Now, the other thing that we can do is we can actually, so just like we can break them up, we can put them together. Putting them together, we got a special word for it. Now, you know, whenever you see a special word, that's probably going to end up as a multi-choice question, right? Now, I haven't seen the question in the quiz that's going to come up after this, but I bet it'll be one on what is concatenation. This is concatenation, where you take two strings and you add them together. What you end up with is a bigger string. All right, so it just puts one string on to, whatever is on. So in this case, whatever's on the left will remain on the left. Whatever's on the right will remain on the right, but they'll be together in one big string. All right, so I have mentioned this a few times already in this lecture that the string is a complex variable and it has a number of different parts to it, each one of those being a character. And so we can know how long the string is using a special function. We've got this special function called len, and what len will do is it will return an integer value, which is how long is that string. We need to use that sometimes if we wanted to have some kind of maybe a while loop, which does something to each individual character in the string. We'd want to know how many times we want to do that, how many characters are there in that string, so we can do something with them. A very good example of how you would use that if you just wanted to have fun, you could write a little program that would reverse the hello, would find out how long it was, and then, take it and add one to the other end. It's that type of thing to reverse. You can do that kind of thing with strings. Maybe we could do that if we have time at the end of this lecture. Have some fun with that. So because a string is a complex variable and it's made up of a bunch of characters, we can take one or two or three or multiples of those characters from the string and get a thing that we call a substring. So a substring is going to be another string which is part of a bigger string. So for example, what this means here, if you look at this string hello is it has index, and each character in that string can be addressed by its index position. So for example, the H is at position 0 and the little O is at position 4. Now with our indexes, we always start counting with 0. I mean, that's just get used to that. That's the way things are in computing. We don't start counting from 1. We start counting from 0. So our 0 position, that's where the H is. So that means that we can do some special things with it. Look at the square brackets here. We use the square brackets to get access to the index of the string, and this has a meaning to it. The 1:4 means we want to get the substring of this variable, and we're going to start from position 1 and all of the positions until just before 4. It won't include the 4th position. It'll just include the positions 1 through 3. So I know it's kind of weird, but that's actually what it means. 1:4 means positions 1, 2, and 3. Don't use 4, but so start with 1 and do everything up to, but not including the last one. Does that make sense? That's how we do it. So we would start with position 1, which is an E. We'd get position 2, which is an L. We'd get position 3, which is an L. And that's why we'd get the ELL. So it's positions 1, 2, and 3, not 4 and not 0. That's how we can get substrings. Other things that we can do with strings is we can convert them from upper to lower case. And so with a string, cases is important, could be used for something. So we got some special functions. If we've created a variable called greeting, we can use this method, the upper, and what that will do is convert whatever's in the greeting string to uppercase. Or we could use lower to convert whatever's there to full lowercase. That could be useful, for example, if you're reading in a password or something, or some special word like that, and it must be in lowercase. Well, you can convert whatever the user inputs to lowercase first, and so you get less errors. Things like that could be used like that, I suppose. If condition, we've already seen this a little bit too. I think what we're trying to get the idea here is, and I've mentioned this already in this lecture, when you see the colon, what that means is everything that follows the colon, as long as you're not doing backspaces and tabs and things like that, is if you, after the colon, you just hit enter and then just keep hitting enter, it will, your editor will automatically indent for you instructions. Then when you're finished, when you got to here, you're finished typing that. I don't want to have any more of this stuff happening when in the true case of that if condition, then you backspace. And the indent is very important. So what this means is, whatever this condition is, if it's true, these two instructions will be executed if this condition is true. If this condition is not true, then the program will just go down and execute this. Now, this last statement will always be executed because there's no else, right? This last statement will be executed because when we finish doing these two things, we'll go to the next thing, and the next thing is that instruction. If, however, the condition is false, we will not do these two things, and we'll go straight down to this instruction. So this is how we do branching. We've talked a little bit about it when we were doing our pseudocode. Branching allows you to process some commands and not others. All right, so now maybe we can have some fun with Python. This is Python code. Some of the things that I talked to you about in the last minutes or two, you can see here. So for example, when you use the input statement, what it does is put a string up onto the screen and the user sees the string, and whatever the user types after that will be a string. And so you need to, if you're going to use it for any Python number calculations, then you're going to have to change it from a string to an integer. So that's what's happening here, right? The user is going to input something. We're going to convert it to a string. We're going to store it in this variable called age. Then we've got an if statement. Here's our condition. And notice when we typed it, we put the colon there, right? And that means that all of these things will be indented after it, as long as we're just typing it like that. And so what's going to happen is we're we're going to create a new function called double. That's going to take whatever the age is, and it's going to multiply it by 2. And then it's going to print some stuff, right? And it converts the age to a string so that we can add all this together as a big string. This stuff here, see all the pluses? The pluses means that we're going to take all of these strings, string number 1, string number 2, string number 3, and string number 4. We're going to add them together. So here we're casting whatever that variable was is going to be converted to a string so that we can add it to this. We're concatenating, right? You saw the plus? When we add strings together, we make one big string. And then here we're going to say, have a nice day. Well, what could we do with that? Let's see. Yeah, let's do this. So Python, save yourself some typing. I'm going to copy that. You can get Python going on your own computer if you wanted to do this just by typing IDLE if it's on your computer. If it's not on your computer, you'd have to install it. How would you install it? You would go to python.org. So that would be, yeah, just type python.org in your browser, and depending on what kind of if you're running a an Apple, or you're running a Windows device, your download will be different. And so you can see that there. We got a Mac operating system or Windows. This is Windows, so I would download this one and install it on my machine. You have no troubles installing it. It's free to use. Put it on your machine, and then you can start doing Python. But it's already on this machine, and you see that I've already got it running here. Now, in the notes, it's going to follow. It's going to say do stuff one line at a time. You've got 2 different screens in Python, depending on whether you want to run something one line at a time. Let's say I want to run something one line at a time. How boring is that, right? And yeah, you can do it like that. And so each line will be processed, and then we go on to the next line, right? Kind of boring. You can do it that way. But if you want to do an entire program and you want to save the program first, we need to use a file. So if you want to use a file, you need a different menu. You need to go and do a new file. You'll see a totally different screen, right? We don't have the 3 chevrons. And so there's a different screen. So this is my first program, which is about your age or something like that. Maybe I should put my glasses. So this is the age double or something like that. A double age program. I'm not going to type it out because I've got it here, right? So I just did a copy and paste, and you'll see the way that that is working is, yeah, what this should do is it should print out for me how many years until I'm double, but only if I'm over 18. If I'm not over 18, then it'll just say, have a nice day, right? Because it won't do these things. It only does these things if this is true. Well, let's see if that's right. Let's run it and see. So before it'll run, it'll have to save it. And so I'll call that age double. Age double, yeah, it's probably fine. And give it a minute. There it is. How old are you? If I say 17, have a nice day. Doesn't do anything, right? Because the condition was false. However, if I run it again and I say my age is over, you know, there we go. This is an old guy. In 65 years, you'll be 130. So you get the idea. So depending on the condition, is the condition true or false? If the condition's true, we go and do these things. If it's not true, we just go on to the next. But we always do the next, right? We always do the next, because if this is true, we go on and do it afterwards. If it's not true, we just go to it. And so that's what happened with that. So let's look at the next one, right? So what if we have an else? We can put an else in it. So now we're getting into the realms. So the last one was just, if this condition is true, do this. If it's not, I'll just go on to the next line. All right, now we're getting into the condition where we say, if this is true, do this. If it's false, do that. True or false. So we got the false stuff will only happen if the thing is true. So, I mean, if the thing is not true. So we're going to have our condition. We'll say something here. This will only happen if this thing is false. This stuff will only happen if this thing is true. This line at the bottom, that'll happen all the time. Well, let's go and see. Oh, that looks familiar. So now we've increased our program a little bit. Got a few more things. I'm just going to copy it. You can do the same at home, right? Just copy, put it into your idle program. So actually, you know, maybe I can just put it in this file, right? There. So I'm just going to update the program with the new improved model. We've got an else in it, right? So basically, if the program is, sorry, if the age is bigger than 18, it's going to do this. Otherwise, it's going to do this other stuff. And it'll say, whatever their age is, well, what's remaining? We're going to create a new variable called remaining. And the remaining is going to be 18 minus your age. And then it's going to say you'll be 18 in so many years. So, okay, let's run it. It's actually the same program, right? All I've done is added a bit of code to it. So let's run it and see. All right, so what's it saying? What was that error? Remaining takes, yes. The problem here is we're creating a variable called remaining in an else statement. So I think that's what the problem is. So I'm just going to go here and say remaining takes a value of 0. See if it'll run then. I think that's the error. It might not be. No, invalid character in the identifier. 18. I'll bet that's still not going to work, right? Wow, I should try this before. Age. All right, so it's age, which is the problem. If age remaining. Okay, age is created here. Takes value. Age is bigger than 18. Otherwise, what was that error? This is really weird. Invalid character in identifier. All right. I don't know. So maybe it's just, maybe it's just like the space. No? Maybe I have to put space where? There was something weird in there because when I just typed it, it worked. So, all right, so 17. In 17 years, we'll be 18. Well, that's not working, is it? String age. Oh, this is this is supposed to say remaining. So we found an error in the notes. All right. I feel good that it wasn't me who wrote these notes. All right, because there's an error in them. All right, so how old are you? 17. You're 1 year until you're 18. It wasn't much of an error. It was just a little error. Anybody can make an error. You know, not that I never make mistakes, because I do, right? So we can all laugh at Mark when he makes a mistake. All right, so but I hope you get the idea there, right? I'm sorry about these little things. And some of the mistakes are hard to see. Obviously, there was a character in there that I couldn't see that was giving us some problem. When I removed it, it all worked all right. And the other thing was that this should have been age, not this should have been remaining. But what I hope you see there is, look, if it's true, we do this stuff. And if it's not true, and the only thing that we did in our test was we did the not true. So let's try it with the true as well. It should be the same result as we had last time. So that looks familiar. And let's do exact. What would happen if I put 17 and a half? I'll get an error, won't I? Because why am I getting an error? Yeah, that's right. Because 17 and a half is not an integer. And when I can try and convert it to an integer, but that isn't an integer. It's not going to work. I mean, likewise. So sometimes you get errors, which are errors because of user input, you know? How old are you? I'm 8. No, you have to put an integer because I was expecting an integer. And so be careful with that. You might get some of those things come up in your programs as well. So we had a bit of fun with that. Yeah, let's keep going. So we've tried that program and that worked all right. Right. So we introduced the idea of the elif. Elif. Can you guess what you think an elif is? Else if. Yeah, in other programming languages, you would say else, and then you'd start an if inside the else, a nested if. So yeah, elif stands for elif because else if, because notice it has a condition with it, just like if does. Whereas this is a proper else. This one means if this thing is false, then we do this. The only time we do this else is if this thing is false, because if the else goes with the last if or elif, right? Whereas this elif goes with this if, and it basically says, if this thing is false, then try this other condition. And if this other condition is true, then we do this. But if that other condition is false, then we're going to do this because we've got an else there. Does that make sense? So we getting ourselves a nice nested if situation, but we need to use elif to do it. Oh, look at that. We're adding to the program. So there now this is the kind of thing, I think we've done this before with like the grade thing, you know, if the grade is more than 90, then say a else or elif. If the grade is more than 75, then it's a B. Elif, the grade is more than 60, then it's a C. Else with no if, and that's all the other things are false, then it's a F, right? So let's do this one. It's the same program basically. I'll have to take all the errors out of it as we go. Yeah, maybe rather than, because we know that this stuff's got an error in it, so I'm just going to do the else so that we don't add any more errors. So let's go there. So this is going to have to, oh no, I need to add the else, not the else. I need, oh, what was it? I need to do the elif. All right, that's fine. Let's go back. So I got to change this. I'm going to change this else to elif, and this is going to be our else, right? Else print you're too young. Have a nice day. I don't want to use the code that they had for the else before because that was an error. So I'm going to change this to an elif, and the condition was that their age was bigger than 12. Oops. I really should wear my glasses when I'm typing on. All right, so we have two conditions. If they're bigger than 18, we do this. Otherwise, we check. Okay, you're not bigger than 18, but are you bigger than 12? And if you're bigger than 12, we get this. Otherwise, if this is false and this is false, we end up here at the else. And at the else, we just say you're too young. Let's see if that works. How old are you? Well, 11. Should say you're too young. You're too young. It seems to work. All right, let's try it again. This time with 20. Should get. In 20 years, you'll be 40, right? In 20 years, you'll be 40. Okay, so that's working. So the 20 was here, right? Age is bigger than 18. Multiply the age by 2. 20 in how many years? You'll be blah, blah. All right, so we got that. And then the third condition, which is, how old are you? 16. Should say, in 2 years, you'll be 18, right? In 2 years, you'll be 18, because in this case, the first condition was false, but the second condition was true. And so we did that. Wasn't that fun? Yeah, maybe. Right. End of program. Right, I don't know, we finished that in 40 minutes. That's the lecture. So it's up to you if you want to do some more Python, playing around in Python, or what would you like to do? I mean, suppose you could start on the lab or tutorial if you wanted. But we do have a lecture time to do that later. It's up to you. What would you like to do? Maybe you should try, have you guys got Python on your machines? Have you? Okay, well, maybe you could try and do these things. I don't know. I guess we're done otherwise. That was fun. All right, so there's only 3 people that were here on time. But I am going to let the rest of you sign in. So make sure you sign in before you leave. Thanks. Any questions? Amira. I think that's the one that I did. Let me get my glasses. No offense, eh? No offense, eh? I did it. Yeah, I just in a grumpy mood today. That's all. Oh, okay. Yeah. Like, Amira, you got it so small I can hardly read it. So let's go back to the program. So I think here. Yeah. Like it better like that. Okay. I'm saying the error is here with the else. So actually, oh, it's this. The print, it needs to be tabbed. No. Tab. Tab. No, not space. Tab. This one. Tab. It's got to be lined. Oh. These ones need to be tabbed also. Backspace. Only one. Only one tab. Go back. Okay, now. So we had this problem before, right? Remaining something one day. So let's remove all the space. Yeah, and retype something. There's something in that had a character. Remove the spaces. So that didn't work. That was because this needs to be remaining. We found that error when I was that was an error in the program. Stop this. It's still recording.